Hi guys, continuing the same chapter Kinematics with part 3, coming for the basic definition regarding acceleration, some MCQs and simple numericals solving acceleration, and then we will come for distance time graph and speed time graph. Okay, so let's start about acceleration. We know that acceleration is simply defined as the rate of change of velocity. Acceleration is simply defined as the rate of change of velocity. And it means that whenever we use the word rate, R-A-T-E, rate, it means that we are dividing a physical quantity by time. Whenever we are saying rate of a physical quantity, it means we are dividing that physical quantity by time. So here we are saying rate of change of velocity. It means we are dividing change in velocity, that is represented symbolically by delta V. So delta V divided by the time taken will give you acceleration, that is rate of change of velocity. We know that whenever the symbol that we use for the starting velocity of the body is u. So what does u represent? The initial velocity of the body. Then the final velocity of the body is represented by v. And if we are going to find the change in velocity, that can be calculated by subtracting the initial velocity u from the final velocity v. So v minus u will give us the change in velocity, and when we divide the change in velocity, that is v minus u, by time, it means this is rate of change of velocity, and by definition this is acceleration. The SI unit of acceleration is meter per second square, that is ms minus 2, and it is a vector quantity. So because from the beginning, when we started discussion regarding displacement, we know that displacement is a vector quantity. Now displacement is actually linked with velocity, because when we divide displacement by time, this makes the rate of change of displacement, and by definition this rate of change of displacement is velocity. And when we divide velocity by time interval t, it means this is rate of change of velocity, and that give us acceleration. So displacement is linked with velocity, and velocity is linked with acceleration. As we know that displacement is a vector quantity, and so the velocity will also be a vector quantity, and because velocity is also linked with acceleration, so acceleration is ultimately a vector quantity also. Okay, and the direction of acceleration is actually the direction of change in its velocity. So whatever be the direction of change in velocity, the same will be the direction of acceleration. Okay, now when we talk about velocity, if a body travels with uniform velocity throughout its journey, that is the body travels at a constant velocity throughout its journey, then we will say that the body is moving with uniform velocity. But if the velocity of the body is increasing, it means that the body is having an acceleration. And on the other side, if the velocity of the body is decreasing, it means that the body is having a deceleration or retardation, that is negative acceleration. Okay, so when we say that a body is moving with uniform acceleration, it means that the rate of change of velocity with time is constant. If we say that a body is moving with uniform acceleration, it means that its rate of change of velocity is constant. Its rate of change of velocity is constant, or in other words, you can say that the change in velocity with respect to time is constant throughout the journey. Then the body is said to have uniform acceleration. Now let's come to the example. A car accelerates from rest. So if we say that a car accelerates from rest, it means that its initial velocity is zero. The initial velocity of the car is zero. It means u is zero. The initial velocity of the car is zero because the car has started from rest. So its initial velocity u will be zero, and then it changed to 50 meter per second. So the final velocity is 50 meter per second, and the time interval for this is 10 seconds. So initial velocity is 0 because the car has started from rest, and then it took a time interval of 10 seconds in which the speed is increased from 0 to 50 meter per second. So u is 0, v is 50 meter per second, and time interval is 10 seconds. U is 0. Why? Because the car has started from rest. It means it was stationary. So whenever a body starts from rest, it means that its initial velocity is 0. And after a time interval of 10 seconds, its final velocity reaches to 50 meter per second. In a duration of time 10 seconds, what you have to find? You have to find the acceleration. Now using the formula of acceleration, that is delta v over t. So what does delta v represent? Delta v represents the change in velocity. Delta v represents change in velocity, and t represents the time. So change in velocity divided by time t is rate of change of velocity. So whenever you divide delta v, that is change in velocity, by time interval t, that makes rate of change of velocity, and by definition this is acceleration. Okay, now the how do we get the change in velocity? To find the change in velocity, we always have to subtract the initial velocity from the final velocity. The initial velocity is u, and the final velocity is denoted by v, and the time interval is t. Now the final velocity is 50, and because the body has started from rest, so its initial velocity u is 0, and then dividing this by the time interval of 10 seconds. So that will give you 50 divided by 10, because 50 minus 0 is 50, and 50 divided by 10 is 5, and we are finding acceleration. So the unit of acceleration is ms minus 2, that is meter per second square. So you may write acceleration unit as ms minus 2, or you may also show it like m slash s square, that is meter per second square. So both are same thing, and both are correct. In this way you can give the unit for acceleration either in ms minus 2 or m slash s square. So by using the formula of acceleration, that is delta v over t, that is change in velocity divided by time. One thing that you have to remember, is how to get the change in velocity. To find the change in velocity, you always have to subtract the initial velocity from the final velocity. The symbol that we have just here for initial velocity is u, and the final velocity symbol is v. So you don't have to confuse that whether you have to always have to subtract the smaller from the bigger. No, you always have to subtract the initial velocity from the final, whether it is smaller or greater. You just always have to remember that to find the change in velocity delta v, we always have to subtract the initial velocity from the final velocity. That is initial velocity u from the final velocity v. Whatever the answer, if it is coming negative, it means that the body is having a deceleration or retardation. Let's assume that the answer for acceleration A is coming with minus sign. It indicates that the body is having a deceleration or retardation. That is, in other words, negative acceleration. And if the answer is positive, it means that the body is having an acceleration. But if the answer of acceleration is coming with minus sign, this indicates that the body is having a deceleration or retardation. So one thing you have to remember here, that in any case, if the answer of acceleration is coming, let us assume, as minus 2 meter per second square. If you got the answer for acceleration of a numerical as minus 2 meter per second square, then in that type of question, whenever you get the acceleration answer with minus sign, usually in the paper, in the exam, they ask you a 1 mark question about the deceleration produced in the body. So if they ask you deceleration, then you will write the word deceleration and you will give this answer of acceleration without minus sign, that is omitting the negative sign, and just write it in positive number. So remember that the word deceleration itself indicates the negative acceleration, that is retardation or deceleration. So the answer of deceleration can never be negative. If you will write the answer of deceleration with negative sign, it means ultimately you are saying that the body is having an acceleration. But in the question, the condition is of deceleration. So if you are getting the answer of acceleration with minus sign, so remember that the negative sign shows deceleration or retardation. So if your answer for acceleration is minus with minus sign, so this indicates that the negative sign indicates the negative sign of A indicates the negative sign of A indicates deceleration or retardation. The negative sign of A is indicating deceleration or retardation. So whenever they ask you the answer for deceleration, so remember that you have to omit this negative sign and just give your answer in positive, that is 2 meter per second square. Okay, then we have another question. A car is uniformly retarded and brought to rest. A car is uniformly retarded and brought to rest with a speed of from a speed of 108 meter per second. So this speed of 108 meter per second, which speed is this? Because if in the question it is mentioned, it is given to you that the car is uniformly retarded and brought to rest, it means that the car is having a deceleration, a negative acceleration. it means that the velocity of the car is decreasing and finally it is coming to rest. It means that the final velocity v of the car is 0 and it has an initial velocity of 108 meter per second. This is the initial velocity u, that is 108 meter per second. 108 meter per second is actually representing the initial velocity u, and because it is coming finally to rest, brought to rest indicates that the final velocity of the car, that is v, is becoming 0. So whenever, remember one thing, that whenever the final velocity is greater than initial velocity, if the final velocity of the body is greater than the initial velocity, it means that v is greater than u. In this case, the body is already having an, always have an acceleration. So the acceleration will be positive. So this you have to remember, that in a numerical, in a question, whenever we are given that the final velocity is greater than the initial velocity, it means that the body is having an acceleration and the acceleration answer will be in positive. But if the question is in such a way that the final velocity is lesser than the initial velocity, the final velocity is lesser than the initial velocity, so it means that u is greater than v. U is greater than v, and u is greater than v, it means that if u is greater than v, or in other words v is less than u, then remember that the acceleration of the body will be negative. The acceleration answer will be negative. It means that the body is having a deceleration or retardation. So they are asking about its acceleration. So here the answer will be with minus sign. The answer of acceleration A will be with minus sign. But if suppose that along with this, if they are asking to find the deceleration, that is what is the deceleration of the car, so you always have to give the answer in positive. You will omit the negative sign of acceleration. So final velocity of the car is 108 and the time taken is 15. Of in final velocity is 0 because the car is brought to rest, so v is 0, and the initial velocity u is 108, dividing by the time interval, that is 15 seconds. So in this way, if you are solving it in this way, 108, u is 108 meter per second, and because finally the car is brought to rest, so the final velocity is 0, and the time interval for this journey is 15 seconds. So the time interval for this journey is 15 seconds. Initial velocity is 108 meter per second, and finally the car brought to rest, it means its final velocity is 0. Okay, the time interval is 15 seconds. This is the time interval, 15 seconds. So time is 15 seconds. Now for finding the acceleration, we use the formula delta v over t. Delta v represents what? Change in velocity. And change in velocity is always calculated by subtracting the initial velocity u from the final velocity v. To find delta V either for acceleration or deceleration, remember that you have to subtract the initial velocity u from the final velocity v. So you have to write the v in positive and u with minus sign divided by the time interval t. Now from the given data, the final velocity of the car is 0 because it is brought to rest, and its initial velocity from where it has started is 108 meter per second, and the time for this journey is 15 seconds. So dividing 108 by 15, you will have 7.6 meter per second square with a minus sign. So here you can see that the acceleration value is with minus sign. So what does this negative sign show? The negative sign shows that, or the negative sign indicates that the body is having a deceleration or retardation. So remember, whenever you are getting the answer of acceleration A with minus sign, so this minus sign, that is the negative sign, indicates the negative sign indicates deceleration or retardation, indicates deceleration or retardation. But if, as I told you, that if along with this they are asking to find deceleration, as I told you that usually if the body is having a deceleration or retardation and you are getting your answer of acceleration with minus sign, then they always ask you a 1 mark question about deceleration. And I hope that now you will remember it, that the deceleration answer is always given in positive. We never write the deceleration answer or value with minus sign. We have to omit this negative sign and just write the answer in positive. So the deceleration of the car is 7. Alright, now coming for the next part. The driver of a car brakes when the car is traveling at 30 meter per second. It means that the initial velocity of the car is 30 meter per second. This is u. This 30 meter per second is the initial velocity of the car. 30 meter per second is the initial velocity. 30 meter per second is the initial velocity of the car. This 30 meter per second is the initial velocity of the car, that is u. And the velocity of the car is reduced to 10 meter per second. So this is the final velocity of the car, that is v. So remember one thing, that if the body is having a deceleration or retardation, it doesn't mean that finally the body is coming to rest. The question may be in this way, that the initial velocity is also a value and the final velocity is also a non-zero value. Even it is lesser than the initial velocity value, but it will not be a zero value, it will be a non-zero value. Like in this you can see that the car velocity of the car is reduced to 10. It is, they are not saying at 0. Okay, it means that the car is not coming to rest. So what is the initial velocity? This is 30 meter per second, and the time the final velocity is 10, and the time taken for this is 5 seconds. So initial velocity is 30, final velocity is 10, and the time taken the time taken is 5 seconds. So now for this question, we have given the initial velocity u as 30 meter per second and the final velocity v as 10 meter per second. It's a non-zero value, but still, because u is greater than v, so whenever u is greater than v, it means that the acceleration will be with minus sign, and it is a case of deceleration. So it doesn't mean that for deceleration the final velocity, or the retardation case, the final velocity of the body is always zero. So it's not necessary. Okay. Now the time taken for this change in velocity is 5 seconds. So this is t. And in the question they are asking you to find the acceleration a. So what is the initial velocity u? 30 meter per second. Final velocity v is 10 meter per second, and the time taken is 5 seconds. The time taken is 5 seconds, and you have to find acceleration. So simplifying the formula, that is delta v over t. So that is v minus u over t, and v value is given to us 10 and u is given to us 30. So 10 minus 30. Now remember, as I told you, whenever you are going to find delta v, that is change in velocity, you always have to subtract the initial velocity from final, no matter whether it is a smaller or a bigger number than the final velocity. Okay, now dividing it by the time interval, that is 5 seconds. So 10 minus 30 will give you minus 20, and minus 20 divided by 5 will give you the acceleration as minus 4 meter per second square, ms minus 2. So the acceleration here is minus 4 meter per second square. So again, because the acceleration answer is with minus sign, it means that the body is having a deceleration or retardation. So if in the question they ask you about the deceleration of the body, then you will give the answer in positive, that is equals to 4 meter per second square. So this is actually the sign of equality, not the minus sign. So deceleration in words is equals to 4 meter per second square. Remember, the deceleration answer is always given in positive sign. Okay, so now we are going to come for the okay, now the other questions are given, like for example in the fourth question, the acceleration is given to us, that is 3.2 meter per second square. This is acceleration, and in this they are asking about that how long will it take, it means how much time will be taken so that the speed of the car is increased from 15 to 22 meter per second. So in this question, the initial velocity of the car is given us 15 meter per second. This is the initial velocity, that is u. This is the initial velocity u, and this one is the final velocity v. So the car the initial velocity of the car is 15 meter per second, and its final velocity is 22 meter per second. So v minus u over time is equals to acceleration, which is given to us 3.2. So in this question we are given the acceleration, we are given the initial velocity u, and we are given the final velocity v. So using the formula of acceleration, you can solve it again by the same formula, that is delta v upon t. So initial velocity is 15 and final velocity is 22, and acceleration is 3.2. Initial velocity is 15, final velocity is 22, and the acceleration is 3.2. And we have to find the duration of time interval, that is how long will it take. So in this example we are given the acceleration a as 3.2 meter per second square. This is acceleration. Initial velocity is 15 meter per second, ms minus 1. This is initial velocity u, and the final velocity v is 22 meter per second. And they are asking that how long will it take, so that the body is having an acceleration of 3.2 meter per second square. Okay, now for solving this numerical, again we are going to use the formula for acceleration that we have learned and memorized so far, that is delta v upon t, and it means that rate of change of velocity. And as I told you, delta v stands for change in velocity, and that is calculated by subtracting the initial velocity from the final one. Dividing it by time will give you the acceleration. Okay, the final velocity is 22 and the initial velocity is 15. The time interval for this is required, so t is required, and we are given the acceleration as 3.2 meter per second square. The acceleration is given to us here 3.2 meter per second square. So because you have to find here time, which is dividing here, so when you will shift it to the numerator at this side, so it will be t multiplied by 3.2, and 22 minus 15 will give you 7. Now because we have to find the time duration t, for that we have to shift this 3.2 to right side of the equation, where it will be divided here like this. So dividing 7 by 3.2, your answer will be around 2.1 second. So this is the solution of this numerical. I hope the examples regarding acceleration that we have done so far will be clear for you. All the best.